Welcome, everyone. So today, we're going to do something a little different. We're going to crack the cloud right open by tackling a pop quiz. And get this, these questions are pulled directly from a course at the prestigious Indian Institute of Technology.
So, you think you really get the cloud, huh? It's so much more than just a place to back up your photos. It's this incredibly complex, layered system of technologies that, well, powers a massive chunk of our entire digital world.
And to really get under the hood, we're going to put our knowledge to the test. These questions are going to be our guide through the fundamental concepts all the way from the bare metal hardware right up to the services you use every day. You ready? Okay, let's jump right in.
First up, we're talking about the foundational magic that makes the cloud even possible in the first place: virtualization. Seriously, without this, there is no cloud as we know it, period.
Okay, here's our first question from the IT assignment. Now, if you've ever installed, say, Linux alongside Windows on your laptop, you've used a dual boot system. But how is that really different from virtualization? Go on, take a second to think about it.
So here's the breakdown, and it's super clear. With a dual boot, you have to pick one operating system when you start your computer. It's a total either-or situation. Virtualization, on the other hand, well, that's a both-and world. It lets you run multiple, totally isolated operating systems at the exact same time, on the same physical computer.
And that is a key. That's the whole ballgame. The magic word is simultaneously. This single ability to run multiple systems at once is what lets one giant server in a data center act like hundreds of smaller individual computers for all different customers.
So how does this magic actually happen? It happens through a special piece of software called a hypervisor. The course material also calls it a virtual machine monitor, or VMM. Think of it like a traffic cop or a manager. It's this layer of software that sits right on top of the physical hardware and basically slices and dices the resources to create and run all those independent virtual machines. It is the engine of the cloud.
All right, let's move on to the next section and see how this all builds up. Now that we know how one machine can pretend to be many, let's talk about where those machines actually live, in public and private clouds.
And here's our next quiz question. You've probably heard of Ubuntu, right? The super popular Linux operating system? Well, they have this thing called the Ubuntu Enterprise Cloud, or UEC, and it's a tool for building clouds. The question is it for building public clouds like Amazon's or private ones?
And the answer is, it's designed for a private cloud. But, that just raises an even bigger question. What's the real difference between the two? It's not just about who owns the servers.
And this table just illustrates the trade-offs perfectly. A public cloud, like Amazon EC2 or Microsoft Azure, is for, well, the general public. It's got low upfront costs and that famous elasticity, that feeling of unlimited resources. The catch? You've got very little control. An on-site private cloud is the exact opposite. It's built for one single organization, giving them a ton of control, but it costs a lot upfront and its capacity is fixed.
Okay, so we've got virtual machines. They're running on different kinds of cloud infrastructure. But how do the apps running on them actually talk to each other?
I mean, this is a huge problem to solve. Just imagine an application written in Java on a private cloud trying to get data from an app written in Python on a public cloud. How do they speak the same language? Well, the answer is a concept called service-oriented architecture, or SOA.
So according to the course, SOA works on this really simple publish, find, bind model with three main players. First, you have a service provider. They create a service and then publish its description to a broker. You can think of this like creating an ad and putting it in the yellow pages. Second, the service broker is that registry. It's the yellow pages where all the services are listed. And third, you have the service requester. They find the service they need in that registry and then bind to it to start talking.
So what's the big deal? The crucial point here is that this whole system works because everyone agrees to use open standards, like XML, to communicate. This model is what solves that massive interoperability problem, letting totally different apps on totally different platforms work together like it's no big deal. This is the idea behind the APIs that let your food delivery app talk to a restaurant's kitchen or your banking app talk securely to a payment network. It's basically the universal language of the internet.
Okay, this all sounds incredibly powerful, right? Super efficient. But moving all your data and applications to the cloud, especially a public one, well, it's not exactly risk-free.
So our next question from the assignment hits this head on. Should a company that's moving to the cloud be worried about stuff like network dependency, relying on the public internet, and this thing called multi-tenancy?
And the answer is a big flushing yes. Both are absolutely major concerns. Now, network dependency is a real issue for sure, but I want to focus on what the course material points to as a massive risk: multi-tenancy.
Just take a look at this quote. It's straight from the IIT lecture notes. Co-resident with the workloads of competitors or adversaries. Whoa, let that sink in for a second. That means your company's sensitive data, your most critical application, could be running on the exact same piece of physical hardware as your biggest rival? That's kind of like sharing an apartment wall with your worst enemy.
And multi-tenancy is just the tip of the iceberg. The course points out several other big ones. You're completely at the mercy of the public internet. You have very little visibility. The provider's internal workings are basically a black box. And, maybe the most chilling one, you can't ever be 100% sure that when you hit delete on your data, it's actually been completely and permanently wiped from their systems.
And that right there brings us to the core dilemma of the cloud. It's a constant balancing act. On one side, you have these incredible benefits of low cost and massive flexibility. And on the other, you have these very real trade-offs in security and control. Making the right call all depends on what your organization does and, frankly, what it has to lose.
So we've seen the cloud isn't just some single thing. It's built on these layers of abstraction, from virtualization that creates machines out of thin air to service architectures that let them all talk to each other. And that leaves us with one last, really fascinating question to think about. What's the next layer? What new technologies, what new ideas are going to be built on top of the cloud?